All right, here we go. So, today we are going to go on to 3.7, which is going to deal with determinants and Cramer's rule. Okay? We will finish up 3.7 tomorrow. Then we will move on to 3.8 Monday and Tuesday. We will test next week, Thursday. Okay? You do have a formative this week, okay, and a test next week. Okay? So formative Friday, test next week, Thursday. Okay? So, what is a determinant? Well, a determinant boils down an entire matrix into one value. And from that value, then, we can use some more higher level mathematical type things. Okay? Like Cramer's rule and inverses. Okay? So we're going to take a determinant, or we're going to take a matrix, and we're going to find its determinant. Now, not every matrix has a determinant. Okay? Only square matrices have determinants. What do you think it means to be a square matrix?
Same amount of rows as columns.
The rows and the columns have to be the same. So a 1 by 1 matrix is a square matrix, and we can find the value of its determinant. A 2 by 2 matrix is square. We can find the value of its determinant. A 3 by 3, a 17 by 17, okay? Which would be nasty. Okay? I think highest we go today is 4 by 4. Okay? Alright? So, we're going to find values of determinants by hand and using the calculator today. Okay? I will tell you this. Sometimes it is faster to do it on the calculator. Most of the time, especially if you're dealing with a 2 by 2 determinant, it is faster to do it by hand. Okay? I will teach you by hand for all of them and on the calculator for all of them. Okay? So, no matter what the size, excuse me, no matter what the size, we're all going to follow one rule. Okay? Before we get to the rule, just popped into my brain, okay? Symbolism. When you have this, that is a matrix. Actually, here, let's do this. Let's go back a page, and then let's go down here, and then let's say, so when you're like this, when you're in the bracket form, that means a matrix. Oops, I forgot the T. Okay? When you're like this, that means determinant. Okay? Or it would, if you have a name for the matrix, like if it's matrix A, you would say find the value of the determinant of matrix A. Or DET, open parentheses, A. Okay? All those mean determinant. Okay? Whether it's written out in words or if it's given in the two symbols. Straight, it kind of looks like absolute value almost, okay? But it would be a matrix inside, it would be the inside of a matrix in between the bars, or DET of A. Okay? All right? So, now, let's do this by hand. Okay? Why are you playing this song? We're playing this song because it's how you find the value of determinants. This is the group crisscross. Okay? Okay? Here it comes. Alright? So, we find the value of determinants by doing criss minus cross. Okay? Criss minus cross makes you want to jump. Okay? Now, we got to figure out what's criss and what's cross. Well, criss is here. So I multiply those two together. So that's going to be A times D. Then I subtract off my cross. C times B. Okay. Makes you want to jump. Okay? Because it's wiggity, 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 whack. Alright? So, let's find the value of this determinant by hand. Okay? Well, that's going to be criss. So here's my criss. 6 times negative 4. Minus my cross. 1 times negative 2. Six times negative 4 is negative 24. One times negative 2 is negative 2. When I'm subtracting a negative, that's really like adding then, right? So this value here, the determinant of A, is negative 22. No. Yeah. Huh? To do that by calculator, the first thing that you're going to do is you need to open up a calculator page. Now, I would start, because you don't know who's used the calculator before you, I would start by turning the calculator on with the on key, and then hitting the on key again, and going into a new document. Okay? I would start by going to a new document, add calculator. Because you don't know what's going on with the calculator before you. Okay? My pre-calculers could have been graphing parametric equations on it, for all you know. Okay? Alright? Then, you're going to get to the calculator page, and then you're going to type in DET, open parentheses. D, notice how it's, for when I just do D, don't tap the brakes, child. Notice when I type in D, it's in italics. When I add the E, it's still in italics. But when I throw the T on there, it switches to regular font. Okay? Just typing in D does nothing. DE does nothing. DET says that it's going to find the determinant of whatever comes after that. Okay? And then I open up a set of parentheses. So now we have to put in that determinant. So we're going to use the matrix shortcut key. Okay? And here's where you find the matrix shortcut key. It is this key right there. Okay? What that does is that opens up all the shortcuts that are on this calculator. So first we've got fractions, then we've got exponents, then we've got a square root, nth root, Euler's number, logs, piecewise functions. Then we go to the second row, absolute value, degrees, minutes, seconds, and then we come to matrices. Then we got summation notation and a bunch of other stuff. Okay? These four are the four shortcut keys for matrices. Okay? The first one is for a 2 by 2 matrix. The next one is for a 1 by 2 matrix. The next one is for a 2 by 1 matrix. Okay? Because we're dealing with a 2 by 2 matrix, we can just go with that one. If we want, we could also go with this one, because that one then allows me to set the size that I want. And so I could say I want it to be a 2 by 2 matrix, and it will put in a 2 by 2 matrix for me. Okay? Then using the tab key, because it's going to make your life go so much faster, you're going to type in the matrix as it's written. 6 tab negative 2 tab 1 tab negative 4. Okay? Then when you hit enter, you should get negative 22. Okay? So we can find the value of determinant using the calculator also. Okay? What I'd like you to do now is I would like you to find the determinant of B both by hand and on the calculator. Verify it using one or the other. So if I'm doing this one by hand, I'm going to have my Chris, which is 3 times 1, minus my cross, which is 6 times negative 2. So that's going to be 3 minus negative 12. So that tells me that the determinant of B here is equal to 15. Verifying that on the calculator, DET of my 2 by 2 matrix, and that was 3, negative 2, 6, and 1. Okay. Alright. 3 by 3 matrices now, or 3 by 3 matrix determinants now. Okay. By hand, it's a little more complicated. Okay. But it's still going to be crisscross makes you want to jump. Okay. Same as it was with a 2 by 2 matrix. First, what I need to do is I need to copy the first 2 columns to the right of the determinant. So that's going to be 4 and negative 2, 1 and 1, 2 and 5. I need to copy those down. Now, I need to get my 3 Chris's and add those to it. So here is my first Chris. Here is my second Chris. And here is my third Chris. I take those 3 bubbles and I add them together. So that's going to be 4 times 1 times 3 plus negative 2 times negative 2 times positive 2 plus 0 times 1 times 5. I find those values, add them all together. Then I subtract off my 3 crosses. First one, second one, third one. Three crosses get subtracted. So then that's minus 2 times 1 times 0 minus 5 times negative 2 times 4 minus 3 times 1 times negative 2. Now I just have to do that math. Okay? So that's going to be 4 times 1 times 3 is 12. Negative 2 times negative 2 times positive 2 is positive 8. 0 times 1 times 5 is 0. 2 times 1 times 0 is 0. 5 times negative 2 times positive 4 is negative 40. 3 times 1 times negative 2 is negative 6. 12 plus 8 is 20, plus 0 minus 0 is still 20, minus negative 40 is 60, minus negative 6 tells me that the determinant here is equal to 66. On a calculator, done the exact same way as it was a 2x2, with the exception of now, instead of being able to use that 2x2 shortcut key, you have to go in and you have to use the 3x3. Okay? But it's automatically, the default is 3x3, so it goes into there. And then again, you type it in using tab. 4, tab, negative 2, and 0. 1, 1, and negative 2. 2, 5, and 3. And that gives us 66. That was just what we just did there. We just found the same one on the graphing calculator. So actually I could probably just put this one, let's go like this. Copy, cut. Paste. Oops, gotta probably be able to see it. Okay. Go for it. det of my matrix, and you want it to be a 4 by 4, and so it then is going to be, if somebody could read it off for me, 7, 2, 1, 6, -4, 3, -5, 2, 1, 8, 0, 0, 1, 4, 7, -7, 453. Come on, paste now. Okay. So we get 453. Again, anything you will not, I will not make you do anything bigger than a 3 by 3 by hand. Okay? But like that. So, where are we going to use this? We're going to use this to solve systems of equations, where it's called Cramer's rule. Okay? Now, Riley just peeked ahead and said, I don't like this next slide. Okay? She doesn't know what she's missing. Okay? Okay? You like this slide. The reason that you like this slide is because this is an easy way to solve systems of equations. You don't have to graph them. You don't have to substitute something in and miss a negative sign. You don't have to try and get numbers that aren't very nice to be the same. Okay? You don't have to do any of that. And it extrapolates into a 3 by 3 situation. So you guys, I know how much you guys love solving 3 by 3 systems of equations. Okay? This will make it go probably in half the time. Remember, like last week when we were doing 3 by 3s and it was like almost a page per problem? We're going to knock it down into, you can really get it done in 6 lines. Okay? If provided you put each row of your matrix on a new line. You know. Okay? All right? Now, don't memorize this slide. Memorize the pattern that is being shown in this slide. Okay? I have never once in my 20 years of teaching memorized Cramer's rule. I memorized the pattern. And here's the pattern that's going on. Okay? First off, down here in your denominators, you have 2 determinants. They're the same. Right? Well, where did we get them? They are the x and y coefficients. Exactly in that order. A, B, C, D. Straight up. In that order. Okay? Then, I'm looking at x over here. And if I want to solve for x, I am going to replace the x coefficients with the numbers. So I took A and C and I replaced them with E and F. Because if I didn't, I'd get 1. Okay? But I replaced them with E and F. Okay?
There was somebody at the door.
Okay? That's right. If I want to solve for y, I'm going to replace the y coefficients. With the numbers. So replace those with the From there, then, it's just finding the value of the determinant on the numerator, finding the value of the determinant in the denominator, and simplifying that fraction. Actually doing that division. Simplifying the determinant on the y numerator, simplifying the determinant on the y denominator, doing that division, finding that number. Okay? Very much easy. Very, very much easier than any other method that we've had. Okay? Let's do it. Let's do one. Okay? So, I got 3x minus y equals negative 8. I got 2x plus 5y equals 6. I want to solve for x. So I'm going to start with the denominator determinant. Written as is. It is 3, negative 1, 2, and 5. Because I am solving for x, I'm going to replace the 3 and the 2 with the negative 8 and the 6. Criss-cross makes you want to jump. So it's negative 8 times 5 minus 6 times negative 1 all over 3 times 5 minus 2 times negative 1. Negative 8 times 5 is negative 40 minus negative 6. 15 minus negative 2 gets me negative 34 over 17, and that reduces to x equals negative 2. You have options here now. You could continue on with Cramer's rule, or you could simply substitute x back into one of your equations and get y. I'm going to continue on with Cramer's rule because I'm already halfway done with y. Why, you may ask? Because the value of my determinant down here on the bottom, 3, negative 1, 2, 5, is 17. It's the same as the denominator in the x one. I've already calculated it. 3 and the 2 return, but now, since I'm solving for y, I'm going to replace the y coefficients with my 8 and my 6. So that gives me 18, or 3 times 6, which is 18, minus 2 times negative 8, which is negative 16. So that's 34 over 17, or y equals 2. What should I do now? Check them, right? Okay. 3 times negative 2 is negative 6. Minus 2 is negative 8. Checks out in the first one. 2 times negative 2 is negative 4. 5 times 2 is 10. Negative 4 plus 10 is 6. Checks out in both equations. So my answer here is negative 2, comma, positive 2. Okay. Tomorrow, when we get to a 3x3 system, it will again be faster to use Kramer than it is to use substitution or elimination. Okay? I'm going to give you tonight's, or the homework now. It is your call as to when you want to get it done. Okay? However, I will tell you a couple of things. First off, I want these done by hand. Five through 15 I want done by hand. If you want to do 30 through 33 with a calculator, that's your call. You can do them all by hand if you want. There's no finding the determinant of a 4x4 or anything like that. Okay? Next, this will be due on Monday. We haven't done a 3x3 Kramer rule yet, so I'm not going to have you turn one in tomorrow. We haven't even done it yet. Okay? Next thing, there is a formative on Friday. Okay? That's all I got for you.